Hey there, welcome back to Farmcraft. I'm John, this is my excavator, and winter is coming.
And winter is coming.
And I've got a lot of firewood to process. We heat the house with wood, and you guys might remember, if you saw my previous video on a certain beech tree, me breaking my log splitter. And I've been thinking about that for a while, and I would really like to incorporate a log splitter that goes on this excavator. And there are a couple of options, and I actually haven't decided yet what I'm going to do. But I'm going to see if I can't put something together to make splitting wood a little easier, a little more efficient, and a little less backbreaking for me. So, here's the deal. Obviously, I have a quick attach on my machine. So, I would need, those are 1 3/4 pins. Basically, I could weld up this frame, minus the bucket, and put a splitting wedge on it. And then I'd have a splitting wedge sticking down right here that I could then press against the thumb, and then I could split against that. My concerns with that are, this cylinder isn't huge. What is that? That's 1.5 inches, I think. It's definitely smaller than that one. I know it's weaker than that one, and I'd probably need this at full extension. Now, obviously, I could put a stop in here so that the cylinder itself isn't being stressed, but it's still going to be holding the weight. And I just don't want to damage anything. Splitting wood, I'm going to be running this thing to max. The other thing is, that cylinder, even though it's strong, it's nowhere near log splitter strong, and it's at a mechanical disadvantage. It's got some leverage here, and then the splitting wedge would be all the way down here. You're just not going to get the force out of this that you get out of a log splitter. Here's my log splitter. Let me tell you about this thing. In a recent video, I was using it, and that cylinder started spewing hydraulic oil, and it was coming from the gland seals, where it usually does. This is a 30-ton splitter. I got it from Harbor Freight probably 15 years ago. They haven't sold this model for a long time. And it's like you'd expect. It was middle of the road, sort of okay. You had to work around things. Now, to be fair, I use this thing splitting huge pieces of wood. I heat with a wood boiler. So the reason I split wood is if it's just too big for me to pick up and throw in the door. So I'm talking about rounds that are like 2 feet across that I would split into chunks that I could pick up. I don't split things down to firewood size hardly ever, as far as like a fireplace. This helps because this hydraulically will lift the log up onto the splitter. But then as soon as you split it, both halves fall right on the ground on either side. And this one especially, now you have to get this all the way around back to the lifter and get it back on there and get it positioned. Basically, this thing will work you to death, and it has worked me to death, and it's worked itself to death. This I-beam is the main structural member on the whole thing, and I'm sure you can see that nice little bow in it. These flanges are all bent up because when it's pushing with 30 tons, and I believe it's a strong splitter, it will start trying to push up off of the bed and bend these flanges. So, I don't know if you can see how bent those are. They're in pretty rough shape. The other thing is, this is a Subaru Robin 9 horsepower engine on here that has never run right for me. It's been constant headaches. Now, people have told me that this is a decent engine. This is the only one I've ever used, and maybe it is. Maybe I could just put a new carburetor on it and it would be okay, and that probably would solve that issue. So that's the third problem. So the first problem is the cylinder needs rebuilt. Second problem is the beam on it is not big enough, and it's all bent up. And the third problem is the engine. And then the fact that the design, I guess there's 4 problems. It just works you to death. So I've been thinking about this for a while, and I thought, I could just do a log splitter restoration and bring this thing back to a reasonable state of usefulness. New carb, repacked cylinder, new beam. But I'd still be worked to death. And I don't want to work to death. At least not splitting wood. Maybe on something else. So, here's my plan. You know what? It's going to be a lot easier to show you, but basically I am going to reconfigure this thing so that I can use it on my excavator. And rather than bringing the logs to the splitter, I will then be able to bring the splitter to the logs with the power of that machine and not my back. So yeah, let's get to work and see what we can do. We need to replace that beam, we need to repack the cylinder, and then figure out how to mount it to the excavator and plumb it in. helps if you turn it the right way. I'll tell you, I was thinking I was going to take the cylinder all the way off and go work on it in the shop, but I've got to get that loose, and it's going to dump oil all over the place. I actually think the easiest place to do this is going to be right where it sits. I'm going to get this stuff out of the way. So as it sits, any oil that comes out is going to drain that way because the whole thing is tilted slightly back. So I'm going to take that foot off of there, and then I'll prop it up at a good height where the oil will at least come forward, and then I can try to catch it, maybe. Now, the other thing I forgot to mention about this is I already have the seal kit. This actually came with the machine, and I have a drawer that I throw all my manuals and whatever comes with it in. This has been sitting there the entire time that I've owned this thing. So now the oil will kind of stack up and then drip into my pan. Yeah? Maybe? Probably not. So now the big question, can I get that gland nut off of there? And of course, that's a spanner wrench I don't have, but I got a punch. Maybe we can just punch it. It's already moving. How about that? So as I started pulling it out, of course, this hose is responsible for pushing the piston back in. So the chamber in there is full of oil right now. So as I pull it out, this is going to pump oil. Well, I had it oriented like this, but it reoriented itself to dump over there. So let's put a clamp on it, and hopefully it'll stay put from now on. Actually put the oil in the oil catch container. Wouldn't that be something? Yeah, that moves a little too easy. That's where it was leaking. Look at that. Got her out. And catching the oil. Gotta love it when a plan works. They often don't. Now, I don't know if that shows up, but there's no scoring on the cylinder wall, the barrel wall. It all looks good. Now this is an interesting cylinder for a couple reasons. One, typically this end of the cylinder would have an eye on it. So the only way you're getting the gland off is to take the piston off. But in this case, I can just take the gland off. Now those are the seals that failed. So wiper, seal, and then it looks like there's also an O-ring in there. Then on the outside we just have a couple O-rings and a backup ring. But those don't move, so those are very unlikely to leak. The piston, it is also O-rings, and of course it has pressure on both sides. It has pressure this way when you're trying to extend the rod, this way when you're trying to retract the rod. And O-ring, backup ring, O-ring is correct. You do that backwards, you're going to be doing this again. I learned that lesson not too long ago on my track adjusters. So the O-ring is what really seals it, and it faces the pressure. So the pressure is trying to push past this O-ring, and the O-ring is not strong enough to not deform too much. So the backup ring behind it helps keep the O-ring, it backs it up, and prevents it basically from getting extruded through the gap. Yeah, if you want to see more on that, I have a video where I did those backwards on my track adjuster and I learned what a backup ring really does and what happens when you do it wrong. So, the only other thing on here is there's typically an O-ring between the rod and the piston that never leaks, and I'm not even going to bother taking the piston off because I don't have to. I can replace these O-rings and backup rings, same here, and then the internal seals, the gland seals, the ones that really matter. Now my thoughts on this cylinder. It's cheaply made, but it's good enough. You know, the rod looks good. The chroming is nice. There's no pits or anything, and I mean, considering it's been 15 years, I'd say that's pretty good. The gland is fine. These are the ones that always fail. This thing sits idle for sometimes years, and that's terrible for hydraulics. So the fact that it lasted as long as it did, I'm fine with that. I think most cylinders would be failing after that much time with that kind of neglect. Hydraulics like regular use to keep the seals and O-rings lubricated. Otherwise they start to dry out and get cracked and fail. So the other thing though is it doesn't have a real type piston seal. You know, this thing's sliding back and forth. There's no wear band. This is definitely a budget cylinder. But I don't use a log splitter that often. Oftentimes I will use it once a year, and sometimes I will use it once every couple years because a year might go by where I don't have wood big enough that I need to get out the splitter. And like I said, that's not good for any type of hydraulic seal, including a good quality piston seal. So if I had a good quality piston seal in here rather than these O-rings, which can take a lot more cycles before it's going to fail, I'd still have the issue. After 15 years of neglect, it's going to start falling apart. Let's be real. I mean, I could set a reminder on my phone to go start the splitter and cycle the cylinder every few months. I'm just not going to do that. I don't have time for that.
Ain't nobody got time for that.
It's basically going to last just as long with the use that I put it through, which is very little use and lots of neglect. So let's get this thing rebuilt. So pressure's over here, backup ring goes there. Actually, let me check. Sometimes these have a flat side and a concave, concave side, and it does. So yeah, it goes that way. So pressure's here. There we go. Now the gland. There we got it. Oh! Almost lost it. Get out of there. Now this is the real seal. This is what's holding the pressure. And this is sort of a real hydraulic seal. It's more similar to the ones I typically see, but it's still kind of chintzy. I guess that's a seal. Not too impressed with it. And then what's the O-ring for? Is the O-ring really what's holding the pressure? The O-ring doesn't even have a backup ring. Alright, so that's the new seal. I guess that's a seal. And this fancy little tool can help make it a lot easier to put in. Here it is. Okay, this went face up. That's your wiper. Pressures on this side, O-rings, and then backup ring. I've never seen two O-rings in a row like that, but it worked until now. It'll probably keep working. So I'm going to put a little grease on this before I reassemble. Thing takes some force to get together. There's the O-ring. And there's the seal. Yeah, that's a lot stiffer than it was. Is it just like grease? Yeah, and obviously I have the caps off my hoses or they'd be fighting me. Torque to spec. Just for good measure, I'm going to stake this nut. It kind of mushrooms it out right there and makes it lock on the threads. So, pretty unlikely to back off. And the cylinder is done. Alright, I'm ready to take the splitting wedge off. It's got a big thick weld at the bottom. I'm going to try to gouge it with my plasma cutter. As usual, using the wrong tool for the job. think we're cutting it. Now that's a real grinder. Ha ha! And there you have it. And we're off. The question is, the new beam has thicker flanges. Will this go on? And I think it will. Yep. That's gonna work. The only other thing I need off of here is these, because that holds the back of the splitting cylinder. Big weld here. I would like to use the plasma cutter to gouge it, but I've got a fuel tank right there. I did drain that, but I'm sure there's still fumes and stuff in it, and I just don't want to go there. Yeah, I'll just use the grinder. This new beam has 1/2-inch flanges where the old one was only 3/8, so quite a bit stronger. All right, we are ready to start sticking this thing back together. So I'm going to put the splitting wedge on there first, and this is 1-inch plate going on to a 1/2-inch flange that of course has thickness underneath in the center, right where I'm welding. So this is pretty thick stuff that I'm welding. My MIG welder is rated up to 5/16 inch, and you can do it with that. Multiple passes, preheating would help, but stick welding is going to do better. I'm kind of new. I am new to stick welding. Stick welding will give you a stronger weld with a better penetration, better fusion than MIG, especially when you're talking comparable price of machines. In fact, you can buy a stick welder that can weld 1-inch plate just fine for much cheaper than you can buy my MIG welder that goes up to 5/16. But stick comes with some disadvantages, namely you have to learn how to do it. So let's tack this thing together and see if I've learned anything. Well, striking an arc is not easy. So you're seeing firsthand why everybody doesn't just go straight to stick welding. So yeah, striking the arc and then maintaining it without it sticking to the workpiece I find pretty tough, especially on this thicker stuff. I'm going to preheat before I do my full weld. That'll probably help with that. All right, here's the results after the first pass. I ran out of welding rod there. Certainly not the prettiest thing in the world. I need to work on getting my travel speed consistent, but it'll hold. So I'm going to do at least a couple more passes with stick, and then I may change over to MIG just to build it up. Stick is a lot slower than MIG, especially for me. All right, I am going to run out of 7018 rod, and I need enough to weld on the supports for the cylinder up there, but I think I have enough to do one more pass right in the center there. So it is spattering a lot. I feel like the heat might be a little high, but I am having so much trouble with the darn thing sticking and getting the arc to form. That's why I've got it turned up where it is. Anyone has any advice for me? If they can see something obvious I'm doing wrong, let me know. Now this is my first real stick weld, so I may be wrong, but I think I'm pretty safe in saying that's not going anywhere. All right, I'm going to do some passes with my MIG. There we are, and I don't think that is going anywhere. So they had a piece of C-channel here that they welded on, provides strength to the flange at the ends. And obviously, it was inadequate. But I do think something like that is probably going to be important, especially at the end with the wedge. The other end, I'm not sure it really matters, but I'm going to put something in there. I don't have any C-channel though. I do have some big pieces of angle iron though. I got those all welded in, 4 of them. Yeah, this is ready to go. It just needs the slide and the hydraulic cylinder on it. But I have no way to mount it to the excavator yet. So that's the next goal. So that's the balance point. So that's where I want my mount for the excavator on the back. Yes, it'll be a little heavier once there's oil in this on this side, but it'll also be heavier on this side if this is extended at all. And obviously if there's a log that I'm picking up with it. So yeah, this is certainly good enough. So this is what I need to make. These 2 pins are, I think they're 1 3/4, and it has a curve in it, I think, so that it doesn't interfere with the mechanism as it comes down. But the excavator has 2 hooks that it has an hydraulic cylinder that it pushes out to grab onto these 2 pins. So basically I need to make this bracket and mount it to the beam so that the excavator can come here and pick this up. Now I don't want to be cutting out these big pieces of steel and get some dimension wrong, so this is clearly a design challenge that requires something pretty advanced, like CAD. So let's do some CAD on this. If you're wondering, this is soapstone, so it's not ink, and flame and plasma cutters and stuff doesn't burn it away. It's stone, so it's just really soft and marks steel easily, and a great way to mark when you're going to be plasma cutting. So you can see these two aren't exactly the same, but that really doesn't matter. What matters is that the holes line up. And I was thinking I was going to drill them separately, but it occurred to me that that is just going to make more work. I need to drill this to 1.780 inches, which is not a drill bit size, or at least not one that I have. But I do have a hole saw that gets kind of close to it, so I'm going to need to hole saw it, and then I'm going to need to bore it the rest of the way to get it to the right dimension. Okay. And I'm also going to have some support brackets here. And now obviously I'm going to need some pins. So those need to be, they're 1.76. I don't have any 1 3/4 stock, but I do have some of this. That's 1 7/8. So it's too big. I need to turn it down. So let's go do that. Alright, so I need 40 thousandths more off. I'm going to do 2 cuts of 20. So there's 20 dialed in. But I'm going to slow down my feed rate. Alright, 20 more and we'll be good. And that's going to have a much nicer surface finish on it, going slower like that. How close do we get to our non-critical dimension? On the money. 1.76 is what I was shooting for. That's exactly what that is. Obviously I could have parted these off in the lathe and put a nice chamfer on it, but this is so much faster. So a couple of things I wanted to point out on my design here. The bucket has one, removable pins. They're not welded in. They have these ears welded on so that they won't rotate. They also have these big bushings on both sides so that they're actually going through, it's 1.5 inches of material. Now the reason for that is because the bucket is going to get used, it's going to get pulled, pushed, over and over and over again, hundreds of thousands, probably millions of times. And if the pin was spinning, it would wear things out. It needs extra meat in here to not wear out so quickly. So good design for a bucket, and having the pins removable makes them easily replaceable. The other thing is the bucket itself lends a lot of support to this, so there's not a lot of risk of this kind of twisting. So over to my design. Now keep in mind this is not going to be used nearly as much. In order to prevent twisting, I'm putting some triangle braces here, and my pins, I'm not going to bush them. I am going to tack weld. I'll put some healthy tack welds on the end, not so much that it'll be a royal pain to ever take the pins out if I have to, but it's just not going to get used that much. There's no way I'm going to wear these pins and these plates out, at least not in any reasonable amount of time. If I ever need to add bushings later, I can just add bushings later. It's not a big deal. And the other thing is welding the pins in is also going to stiffen everything up, because now the two plates are actually tied together. So it should make that nice and strong. Here it is after tacking it all up, and everything looks good. More importantly, the space between there is exactly what it needs to be, and the space between there is what it needs to be. That's what really counts here. Other than that, it just needs to be strong. Let's get it welded up. Welded up pretty good. A couple areas are a little ugly. I just tacked the pins. I think that'll be fine. So I do need to paint it, but right now I want to pick it up with the excavator so I can see what I'm going to need to do as far as hydraulic plumbing. Well, the mount works. I'm trying to think about how I want these hoses to run now. So the excavator is set up with 3/4 inch hoses and quick connects, so it can do a lot of fluid. The log splitter was originally plumbed with 1/2 inch. So if I upgraded to 3/4 inch lines, it would probably cycle much faster. That said, I've never felt that this splitter was particularly slow, and I already have the 1/2 inch lines, so I'm going to try those first and we'll see how it goes. Buying a new set of quick connects for it is going to be expensive enough. Adding 3/4 inch lines would make this quite expensive. So one thing that's been on my mind from the beginning is that extension. I welded this on years ago because I'd have a big log on here and it would start pushing on it and the log would end up skipping up off the top of this splitting wedge. So that would kind of catch it and make sure that it started to split. Not an issue now, because I'm going to be able to push down with the excavator. The log's going to be trapped between the splitter and the ground. So I think it's going to be much easier if that's not sticking way down. So I'm going to cut that off. That POR 15 needs a top coat to protect it from UV. Honestly though, I don't know if I really want to do this yet. I haven't even tested this thing. This is like signing it before I know if it works or not. I kind of like it. I don't want it perfect. Nothing I do is perfect. So my control for the thumb, or I guess more correctly to say the aux hydraulic circuit that you can hook the quick connects to, is this pedal right here. When I push the right one, it sends pressure to the right fitting, and when I push the left, it does the opposite. It sends pressure to the left fitting. So obviously when I hit the right pedal, I want the splitter to go that way, and that would be retracting the cylinder, which is this hose. So this hose needs to hook to the right side, this quick connect, and the other hose to the left side. I've got a JIC coupler here. One hose isn't long enough to reach. This is going to go up through, and that'll keep that hose kind of safe out of the way. I've got the thumb ratchet strapped up because it's disconnected right here. So then basically there is going to be my quick connect. Right. So now where it comes through there and it's contacting things, the hose is protected from rubbing. You know, you guys could have said something. Yeah, that is supposed to be hooked to this. Best hose I have has a 90 in it. Oh well, it's free. I'd rather test these out. I think if I'm going to buy new hoses, I'll go bigger. But if these work fine, then I'm just not going to worry about it. Yeah, that doesn't move, so that's actually fine. Now, obviously, if I was going to be using this splitter for hours and hours on end, day after day, I would plumb this better. But certainly for testing, and probably for me, this will be fine, because I'll use it for a day or two, and then I'll be taking it off and putting the quick connects back where they belong on the thumb. So yeah, this thing's actually ready to test. That is really fast. In fact, much faster than it's ever been in the past. All right, next thing you're gonna see is me out splitting some wood.
So this is the first real test, the first log with the new splitter. I must say I was a little worried that I would start putting some pressure on it and one of the hydraulic hoses or the cylinder would blow out. Would you look at that? That shit actually works. There's a bit of a learning curve here. I get better over time after spending a few hours in the machine of manipulating the logs into position. So you might be wondering what my total cost on this project was. Well, I got that beam from a friend who gave me a really good deal, and I had to buy new quick connects and a couple hydraulic fittings. Other than that, it was just welding supplies. So throw your guess down in the comments. I'll tell you the total in just a second here. And here's log number 2. So my total cost was $250. 140 of it was the quick connects. So how close was your guess? What do you think? Money well spent? The splitter is definitely faster and seems stronger than it's been in the past. I think that's because the hydraulic pump on the excavator is far superior to what was on that little unit, and it builds pressure and gets to the 3000 psi much faster when it starts to encounter resistance. This thing's just splitting like nothing. Now this next log is the bottom of an oak tree, and the bottom log often is hard to split because the grain is flaring out. So let's see how it does on this. To give you a little perspective on how big that is, the beam is 6.5 inches tall and the splitting wedge is 12 inches tall. That's a big log. It didn't even flinch.
Well guys, I can tell you that is the most enjoyable time splitting wood I've ever had. I am not tired at all. Can you imagine? No, that thing works great. It's fantastic. I was worried it would be too long and there would be too much slop in like trying to manipulate the logs with it, but it's fine. It's super strong. It moves fast. It didn't even flinch. I mean, these logs were dead trees, but I mean, that's oak. And these things are big logs. Yeah, that would be a lot of work to split those. And here I am sitting here in an excavator with a fan blowing on me. Life is rough. The splitter is a success. You know, using it, I do kind of think I probably ought to put something over that cylinder to protect it. And make sure those hoses are protected too, because I'm using it to manipulate logs. I'm looking over here and I'm not looking at that. So I probably need to put something on that. But wow, I don't think I hate splitting wood anymore. This is actually fun and easy. Sweet. This is a 28-inch bar. That's a big log.
So I don't know how long it would have taken me before with the old splitter to split these 3 logs. I'm guessing it would be about an hour, and it would be a lot of back-breaking work. I'd be manipulating these rounds and then the halves to get onto the log lifter, and I'd be pretty tired at the end. So maybe even more than an hour, but I think an hour is a reasonable estimate. So let's see how long this takes. I'm going to play it at actual speed. If you're bored with that, then go to 2x speed on your playback. here I am finishing it up. How long do you think that took? Looking at the actual timestamps on the footage, it took 7 minutes.
Well, there you go, guys. Sort of a DIY log splitter. Taking an old log splitter and making it into something a lot better. That might be my new favorite tool for a little while. I'm real happy with how that came out, and thanks for watching. We'll see you guys on the next one. I've got more firewood to cut. So what do I do with this? This is one of those things that actually seems like it'd be fairly useful, but I can't think of anything right off to use it for. It's got a cylinder, although a weak one. It's got controls, an engine that I can certainly get running, a hydraulic pump, a hydraulic tank. I mean, I basically have a portable hydraulic system here. What do I use that for? Nothing's coming to my mind, but if you have any ideas, leave a comment.